So let's continue with the code. Let's select the Python Skyline node, visualize it, and click on it, and expand our window. The script we'll be writing is going to be around 100 lines, but it shouldn't be too difficult if you followed along with the previous parts of the course. Let's start by importing some modules that we need. Who should already be imported, but in either case I want to do it anyway. Import who, and we're going to need a function from the math module later on. So just import math. We can remove these two lines, we don't need those. And I'm going to block out the code for you again as usual, so that you have an idea of what's going to happen. First, we're going to get the height data for each building segment. Then we're going to prepare the base point cloud. And by that I mean that our base point cloud will have all the attributes we need to then pass on to the points that we're going to be stacking on top. So at some point we're going to be setting the height values. And this includes the system we just built with our painting. Then there's going to be some code where we will retrieve position data for each point and calculate the number of building segments. And that's going to be a calculation of the maximum height or the skyline height divided by the number of segments. Then we're going to create new points on the stackable buildings and set attributes accordingly. And that part is going to be separated into three parts. The first midsection, that is the first midsection of each building. Then there's going to be the second and onwards midsections. And lastly, we're going to be working on the top section of each building. The code for these three pieces will be fairly similar, but there are going to be a few small details, and I wanted to separate them into these three parts so that it's obvious to you what exactly is different and why. It also makes it easier for us to then later add code per section. If we'd consolidate the code, that is going to be more difficult to achieve. Let's start at get height data for each building segment. We're going to build a dictionary, building height dict, and we initialize it by opening and closing curly brackets. And then we're going to be retrieving some nodes from the buildings node. Let's jump up and then into our buildings node to have a look. So if we remember, before we imported buildings into this node, and we had our code laid down in attribute create node, on which we had a number of values. These attributes were building ID, building height, and building type. We want to be retrieving building ID and building height because we want to couple them so that we can stack them correctly. There's values on there, value 1v1, and here is a value 2v1, because this one is the first value, and then the first index of that value, and this is the second value, as it is the second attribute we've created, and the first value of that attribute. We'll be calling these. Let's go back up and back into our Skyline node. So we're going to be looking for children in that buildings node. We're going to be writing children is who.node, and that node is /obj/buildings. .children will then retrieve the child nodes from that. By unselecting the Python node, it compiles the code inside, and we can see that it doesn't error out. We'll be writing a lot of code, so it's always good to check that whatever we're doing is actually working. Let's write a for loop over these children. For node in children, finish with a colon, and again 4 spaces indentation, of course. If attrib create, and attrib create is going to be a string in node.name. So we know that node.name is a function that fetches the name from the child nodes, and in this case it is checking if attrib create is part of that name, so that we can filter that way. Print node.name. Let's see if that works. It's erroring out for some reason. I forgot a colon after the if. And there we go. We have them printing the name of the nodes. Keep in mind though that I'm on a Windows box, and that's why I get this pop-up console. If you're doing this on a Linux, it most likely prints all this information to your terminal from which you're running Houdini. So have a look there. So let's continue. We can remove this. Building ID is node.parm. And here come the values that I've just explained. Value 1v1.eval. So this is going to be looking at value 1v1 parameter on every attribute create node in buildings. So we can then later couple that with value 2v1, which will be the building height. Let's build that as well. Building height is same code, node.parm. In this case, value 2v1. And again, .eval for evaluate. Then we're going to pipe those into the building height dict that we've initialized. And that goes as follows, building height dict. And as a key, we're going to set the building ID. And the value to that key is going to be building height. And just for precision's sake, I'm going to make it into a float function. It should be by default anyway, but just in case any building is exactly 1 or 2 or 3, I want it to be 3.0, 2.0, just for consistency's sake. So what this will do, let's try and print it out, is pair all the building IDs with the building heights that belong to them. Let's do print building height dict. And then simply by selecting outside the Python node, we should have it printed in the terminal. There we go. And we still have these old attribute creates in there. So we can see that building 1.0, 2.0, 3.0 are these height values. One thing I want to change is make sure that the building IDs are actually entered into the dictionary as integers and not as floats. So let's make sure that we do an int function on the building ID. All we do is write int before building ID, and then in between brackets we have that building ID, so that it looks like this. And now we have integers instead. We had 2.0 here, and now we have 2. We had 1011.0 here, now we have 1011. Let's clear that and close that. This is exactly what we want. This part of the code works. Remove that print statement. And let's continue with preparing the base point cloud in the next clip.